I stand here before you between you and freedom to go home or to go do something else. And some of you may not want to go do some more beers because I've seen a few faces last night that had enough. My name is Pierre Roman. I'm a senior cloud advocate with Microsoft. I work on a team in developer relations, but I have nothing to do with developers. This is a point of contention between me and April, because she keeps telling me that we're all developers, and I keep telling her that because I use some developer tools and I write some code, I am not a developer. My team covers modern infrastructure, which is everything operations, hybrid, cloud on-prem, whatever. Security, guidance, governance, which is often something that people don't think about. I had an episode where the governance wasn't set properly as to what kind of machines we were allowed to run, and in the demo, in my infinite wisdom, I created a 10-node availability set of G5 machines. And then after the demo, I went back to the podium, thank you very much, closed my laptop and went home. Ended up with a $78,000 bill at the end of the month. Because contrary to popular belief, even if I work for Microsoft, I do have a budget for my subscription. Which today, we're going to talk about, and when I say feeling triggered, is really because I want to avoid the problem. Because problems trigger me. I get anxious, I get angry, my ADHD kicks in, my dyslexia kicks in, the more agitated I get, and then I can't do things. So I'm always triggered. Some of the problems that trigger me is that large scripts are problematic. Who here likes to write scripts that are 100, 150, and plus lines? One.
All right, sorry, what was the question?
Do you like writing long scripts?
No.
No. This presentation, by the way, is not really about PowerShell, but it's about how you execute and how you line up your PowerShell. Because the PowerShell community, and I've been talking with Jeffrey and Jason for many years, where we advocate for small task-based scripts. So instead of running that 150-line piece of code, that if something breaks or if you want to change something, you end up breaking 3 other things inside your code. That never happens, right? Of course not. We advocate that you break it down into tasks and then call these tasks when needed. However, executing that task when appropriate is not always easy. It has blind spots. First of all, task scheduler is inflexible. I hate task scheduler. It's a necessary evil that I would like to take at the back of the property behind the shed and put a bullet in its head. Cron jobs are the task scheduler of Linux. I know they're necessary. I know we use them alone. Who here uses that to schedule and run their scripts? Okay. So you know what I'm talking about. Passing dynamic parameters to your script when automated, like not the scripts doing the automation, but automating the execution of the script, can also be problematic. Because if you're waiting for an event to happen to be able to pass a parameter to a script that's going to do something based on that event, if it's scheduled, what do? There are ways to do it. You generate an environment variable and have your script read the environment variable. But it's not always clean or easy. Script polling, where you run a script and it runs for 24 hours, and after so many hours or so many minutes, it polls to see if something did happen, and then it goes back to sleep. I have seen some like that. Run 24 hours a day. And for some reason, the event that they're waiting for, they always miss it. or by the time they get to it, it's too late. So inefficient, not of something that I would ever recommend, but I have seen it in production. I have seen it in production in a cloud environment where a VM was there running approximately 12 different scripts, 24 hours a day, all the time. So they were paying for a VM to run just so that those scripts could pull. So everybody in this room would kind of look at that sysadmin and say, get the fuck out. Yes, because you don't want to do that. But I've seen it in the field. So we as a community have got some education to do, because that can't be done. Oh, and did I mention I hate task scheduler? Very, very much. What we want to avoid going forward is this. The person that has to sit at a desk or something and then wait for the event, and how do we simulate that? How do we automate Omer to actually start it when we need to start it at the time we need to start it? Triggers. Triggers in PowerShell. What are the triggers that you normally use when you're running your scripts? Events on Windows. When you're not running in Windows, there's multiple kinds. So if we look at the agenda, what we're looking at today is functions and logic apps. We are basically going to build, actually the slide was out of order, but with the logic apps and functions use tremendous amount of triggers, and some of the benefits address the problems that we've identified. And I've been asked before, and I know that this audience here probably already knows that, but what's serverless? Like, does that mean there is a server? It's just not your server, and you don't have to worry about that server. In Logic App, it's a container. No infrastructure to manage, don't have to worry about it. Stateless, so it runs, it disappears, doesn't save anything. Don't have to worry about temp files or config files. Well, you do, but not while they're running. Scale, dynamic resource allocation. When you need it, it's there. When you don't, it goes away. It doesn't cost you anything while it's not running. It's event and scheduled based as well, so you can do a scheduling, but you don't have to. And generally used for microservices. But I would say that turning our PowerShell scripts into microservices is the way to go in an environment where you're automating management and operation within a large hybrid environment, or even a small hybrid environment. So it has a set of cohesive tools. So we're looking at Event Grid, Data Factory, API management, functions, service bus, logic apps. All you need in order to effectively start and run your scripts, your workloads, when they need to happen, at the time they need to happen, and to also communicate between each other. So basically, we're putting the people, apps, and data together through a series of soup. Function Azure Functions, no, my dyslexia just kicked in there, are the main part of this. Because logic apps can very easily do this, but when it actually takes the time to run the code, you just call a function. Function runs the code, returns the data. Running these two together has tremendous opportunities in terms of management, and we'll go through that. You get your code, which is PowerShell, C++, C#, F#, number of different one, Node.js. My old boss wanted me to learn Node.js. I said, never mind, I got PowerShell. And then you send the results or the output to a multitude of different endpoints. From those endpoints, you will generate triggers for the next piece of your code to run. So maybe you're passing the machine name, a user account. Regardless what your workload output is, you're passing that to something else. Now there's another script somewhere, another function that's waiting for that something else to happen. When it does, reads the payload, says, okay, machine demo 1-VM needs to be restarted. Passes it on to a queue where there's a worker script that's just sitting there waiting for input to see which machine I need to run. Same thing with logic apps. Again, stateless. There's new extension for VS Code. I stole that slide from a marketing deck. The one thing that we need to be conscious of, hundreds of different connectors, and that list is growing. So it doesn't matter what you need to happen, there's probably a connector in order for you to monitor that and trigger your application or your workload when it needs to happen. And the benefits, it's event-driven. Don't have to use, ever again, Task Scheduler or cron. This is just a quick screenshot of some of the events that Azure Functions triggers that are built in. So blob storage, Cosmos DB, Azure SQL, so anything written to a table in one of those databases. Dapper, Event Grid, anything that happens to the Azure Fabric is popped into Event Grid, so you can, depending on which action is being written to the grid, you can monitor it. Did you have a question?
Yeah, I've got a growing thought in my head because I actually work primarily in the Power Platform.
Yep.
And looks like a lot of my work is in Power Automate, which
Very similar.
Mirrors. I'm trying to figure out like when it's more appropriate to use one or the other, because they kind of run
Very similar.
Yeah.
Very, very similar. At this point, whether or not you want to use Power Automate or Logic Apps or functions, I think Power Automate has a bit less code to be done versus Logic Apps in terms of how you're connecting, how you're setting up your Logic Apps or your functions to actually have bindings to like a storage account where you actually have to fill out some JSON.
Yeah.
Other than that, I think it's up to what you're familiar with. The point is really to take advantage of the triggers that you have to run scripts when they need to without having to go back to Omer.
Yeah.
So if you're already using Power Automate, you're already there. But that's another option for you.
I think also there's less limits on Logic Apps as opposed to Power Automate, correct? Well, depending on licensing.
Depending on licensing.
Yeah.
So this, in terms of pricing, since we're talking about pricing, there's a price. It depends on which app setting or app service that you pick, because all of these are backed by a app service in Azure. So if you're using one that's consumption, there's a price per execution, plus the storage, because there's always storage in everything you do in Azure, because you got to store your code somewhere. But a 25-line PowerShell code is a text file. It's not going to break the bank. It's not like we're storing terabytes of data in that, which you could, but anyway. And then we have Logic Apps, and this is just a list of the triggers. I was going to put them all on a slide, but then I just like it got too long, so I just recorded me scrolling through the page that lists them. Still scrolling, right? So just to show that the possibilities in terms of what you can leverage to trigger your scripts is, well, it's not endless, but it feels like it's endless, especially when you're watching this slide. And this is not on the loop. This is still just the same page scrolling. And you can see the little bar here coming back down, about 3/4 into it. So we want to take our scripts, and I am guilty of having done this in the past. where after my G5 debacle and having to explain to my boss why I just spent $80,000 for no reason, I wrote a large script that would run through all the resources in our demo subscription, identify the tags, so something that was persistent would be ignored, anything that was non-persistent would be shut down on a regular basis. It would run, again, on a schedule every night at 11, my time, 11 Eastern time. So it would enumerate the machines. Then it would pull all the tags for those machines. Then would sort through the tags and filter the tags on the ones we needed to do. Then would start the machine. Then would wait to see, or stop the machine, sorry. And then would wait to see whether or not the shutdown was successful. So it would go to sleep. But sometimes the machine takes longer to shut down than the next one, so if my 20 seconds or a minute that I made it sleep is not quite long enough, then again, my report doesn't show me. Then a whole bunch. And every time I went in and tried to change something, I would break something else in my script. It was long, it was annoying, and therefore not very efficient. Logic apps and functions are extendable, and they are secure. Who here puts credentials in their scripts? Good, because if any of you put their hands up, get out. But it's a lot more frequent. Do you know that we have there's a bot that scans all public repos on GitHub and looks for credentials? Internally at Microsoft, there's a policy and a scan that happens in all of our Teams chats. In chats and in Teams channel. For anything that has credentials in it, it gets flagged, manager gets notified, message gets deleted. And you would be surprised of the amount of time it gets caught. Never, never, ever do that. So secure, very secure. Now let's stop doing and go into some demos. Got 25 minutes, we're good. So to create a, let's just say that for now we're going to create, it's going to be a cooking show, I've already done it. I learned from April this week, who basically trashed her whole demo because she couldn't connect. We're going to make a microservice using PowerShell that will first read the status of our machines and store that somewhere. Then we're going to have another function that will be triggered by that list of machine being stored in a queue. It will take that and will identify which ones are turned on, which ones are turned off. And considering I built these demos yesterday or the day before, I did not check the tags, but this is very possible and very easy for all of you. Like, all of you are better coders than I am, because I don't do it a lot anymore. And then it will report to another queue that it's been done. From that, a logic app could monitor that queue, get the info, parse it, and send it to an email account, send it to a Teams channel to identify this is what's happened, so that you don't have to go to a dashboard. I know who's in management here? Okay, you are the exception to the rule. Everything I'm going to say about managers does not apply to you. Does that work? Because a lot of times you give management access to read-only dashboards because they like pretty pictures. They don't understand when you give them lots of data, but they like the pretty pictures and the graphs. If it's going up, they're happy normally.
Even if it's not backed by data.
Exactly. So that's why you always give them read-only access to your subscription and don't allow them to do anything. So that's what the solution that I built, mostly. So if we want to create something like that, it's easy. We just go to, and all of this can be done directly in PowerShell. I chose not to, because it's not really about PowerShell at this point. So I go and just create a function app. Can you see okay, by the way? A little fuzzy, but all right. Let's find a user group. We'll call it demo 3 PowerShell. I get to figure out whether or not I'm going to be, my function is going to be running a container or just some code. In this case, I'm just going to some code. Then I select what I want for my language. This course, PowerShell Core. 7 and 7.2 are currently supported. 7.2 is in preview, so I prefer in production never, ever to use previews. Because as much as they're fun and you can experiment with them, they can change at a moment's notice without any heads up. So something you put in your code on a preview next week won't work. So never a good idea. And then I put it in East US because that's closest to me. Maybe not today, but then we figure out whether or not we want to run on Linux or Windows. Of course, because PowerShell Core is multi-OS, open source. I'm going to use Windows because I need it. And here is where we decide how much it's going to cost us. Consumption, cheapest, serverless. Premium and app service plan give you opportunities to have your function never go cold. So they're always warmed up, they're always waiting to happen, but there's a cost to that. If you go to consumption and your code hasn't run for an hour or 10 minutes, I can't remember what the actual timeout is, it will actually unload your code. So your code goes dormant, it goes cold. When the trigger is triggered, it will actually start the container, load the module, so it'll take a little bit of time. So it could take like 1 or 2 minutes to get to it. In our case, I'm just going to go app service plan for now because I've already got a service plan that is available. And do I want zone redundancy? Not at this point. Storage account, as normal, it'll ask me where do you want to store that. You can pick any of the one you already have, or you can create a new one. For stuff like that, I like to create them individually, and it's just an organization thing. It doesn't cost anymore because it's just a matter of how much data is stored, but it's how you organize your files. And the networking is basically whether or not you want this to be accessible from outside. So if it's something that only runs internally, the triggers are only internal based on event grid, based on other things that are happening within. So if you're not going to have an HTTP trigger, like a webhook, then you could turn that on and basically lock up your networking. In my case, I'm just going to leave it off. Monitoring, if your code can be monitored by Azure Insight or Application Insight. So it'll get your exceptions. It's really good for debug, so if something happens, it will log it. In my case, I'm just going to say no for now. Tags, because I have learned it's a demo, lifecycle, non-persistent, so my other function in my management resource group, when it runs at 11 o'clock tonight, we'll look at all of that, and if it's not needed anymore, we'll just either shut it off or get rid of it. And I create it. Now, let's jump to a cooking show because we don't want to wait for this to deploy, and jump to our PSHSummit that I've already created. The important part, number one thing I always do when I get to this is identity. We talked about putting credentials in scripts. In your scripts, one of the good things you could do is if you need a credential while you're executing, what do? Go to a vault. Access a vault, pass your secret, not pass the secret, get the secret that you're looking for, and then do something with it, and then it disappears. Never written down. In our case, what do we do about the access of the actual function? So in this case, I'm going to create a system-assigned identity. A user-assigned identity is basically the same thing, but you have to be done manually. In this case, if it's system-assigned, when I delete my function, the identity will be deleted with it. If it's a user-assigned, it's managed as a user in your Azure AD. So in my case, I just go system-assigned. And when I save it, I say yes. It's going to enable it, it's going to create an identity, and it's going to return the object principal. Now, I want to go back to my subscription, because maybe my script is going to affect more than the resource group in which I created it. In this case, because I'm looking for VMs, I'm going to look across my entire subscription. It's a demo subscription. There's absolutely nothing wrong to have subscriptions, a lot of subscriptions within a tenant. So you have subscriptions that run for marketing and subscriptions that runs for engineering. Or that way you get better view of how much each of those groups are costing you. And you can also put them into management groups so that if you assign a policy, you assign it to the management group, and then it trickles down to all those subscriptions. So it's just another way of organizing your environment. And I'll go to access control, and I'm going to add a role assignment. And of course, I'm going to make it, you can make it a reader. So if it's a script or a function that only takes information from your subscription, just give it reader. So even if it gets compromised, even if somebody puts something dangerous into a script, somebody found something on a gallery somewhere that said, ooh, that looks cool, cut, paste, execute. Where did all my resource go? Anybody ever done that? No shame. No shame. Okay, you did. I did. A friend of mine, a contact of mine, did that and was trying to test it in a sandbox, except he was logged into production, erased all of the application containers in Active Directory. So SQL was gone, Exchange was gone, all was gone. And that's another session though, but their disaster recovery plan was not good. And their last good backup was 6 weeks old. So that was fun. So in this case, we're just going to I'm going to say just contributor because of that, but you should be very granular into what that script or function needs to do. I know it's a bit more work. What do developers normally do at this point? Domain and bin. Say next. It's a managed identity. And select my members. Got my function. PSHSummit. Select. Assign. Done. Now that function will run within the confine of the identity and the role we've assigned it. So we've assigned it a reader role. If it's trying to write something anywhere in the configuration, it won't work. If it's trying to write a message in a queue that's been configured with the proper access key, that will work. It just can't change the resources within Azure. It can just read the info.
Did you do contributor though? Did I miss something?
Yeah, just the contributor because that's just a demo.
You're saying if you would have done reader. Okay, sorry. I missed it.
Yeah, if you would have done reader, that would have applied. This is a cooking show, so I'm not actually going to deploy this one. And then you end up with something like this, where once your identity has been set and you have proper environment, if I go to my application files, so the application files are what basically drives all of your functions, the configuration, the access, the connectors, all of that. So the host.json is how your, I wish there was a way to push everything up. Is how the host, so when your script is instantiated, that serverless container or instance, it's going to use the information in that to figure out how it's going to run. And in our case, I've added the logging, because I want to be able to debug with more information than just an error has occurred. Because that's always useful, right? I got my extensions, and I've got the extension for my queues in terms of how often I pull the queues, or that the functions will pull the queues that it's monitoring. Also has the profile, and in the profile, if your MSI secret is there, then it'll connect with the AZ account using the identity of the function. This is where the function actually logs in to Azure using that identity. That identity is not written anywhere, it just gets it because of the managed identity that it's in. And then we have our requirements. I've added to this one just Azure Resource Graph. Because in my scripts, I'm going to use resource graph instead of the get VM, and which you can use. But in some scripts, I'm using resource graphs because it's more the custo language, a little bit more granular than just get VM. So you can have your scripts take advantage of Azure Resource Graph in order to get the data. So I'm already loading this as a prerequisite.
I just wanted to nitpick you here. You may want to comment out the AZ on the top, because that's going to grab all modules regardless.
Yes, except Azure Resource Graph is not part of that set.
Right, but you still have it in your managed items, so it'll grab all that and grab resource graphs. Your cold star's going to take forever.
I understand what you're saying, and I think you're right, but somehow it wasn't working until I had it.
Okay, probably. If you tested it, yeah. There might be a component of it that you're using.
I don't know, probably. But yeah, so I was having problems. It would give me errors on the my graph call. And then I looked at somebody else's example, and they added in, so I went, what the hell? I'll just try it. Put it in, and it worked. But considering I built all those demos 2 days ago, I did not have time to research it. But good point. It should have just done everything that's AZ.
Yeah, you can load the components of AZ without having all the whole set.
Yeah.
Specify them.
Then, of course, we have our service plans, which we can do. Tools that we have is the console for debugging, for running stuff, and in it are all of the files that we have, are basically the PowerShell scripts, our requirements file that are going to be running inside of our functions. Advanced tools to allow you to debug a bit more, go actually into the files, and give you a little bit more control over. So the debug console, the only thing that I have a problem with, and I've reported that to the Azure function team, is I've already said I want PowerShell core. The PowerShell version that's running inside of this console is the Windows PowerShell version. So right off the bat, when you're trying to debug and you're trying to test things, you're not using the same version of the PowerShell in your function and to test and debug your function. It's a problem. They know. Apparently they're working on it.
I was gonna say, have you used Azure Functions core tools before?
Yes.
Okay, I was gonna mention.
Yeah, but if you're in the portal,
Yeah.
there's that. So with the Azure core tools and VS Code, you get access to all of that same information here, and then you can run them locally in your terminal on your machine. So a lot of different ways you can test and troubleshoot your environment. So in my case, I'm going to close this. I have the functions that I've created. And for to test one, so I've got get my VM status, which is a HTTP trigger. HTTP trigger just because it was easy to set up for a quick demo. And I just send it with my code, which is the identity, because this is not anonymous. So you need a key to actually run and connect. That key can be for all of your functions, for a specific function. So you have your keys. Example, we'll go to my VM status report, and I got the function keys there. I can create new ones. So this one is the default one for that function. So you can have a specific key per function, so if it gets compromised, you just regenerate that one, not all of the ones. Yes, it's a lot more management to have individual keys for individual functions, but it's more secure in the end. And of course, if you want to add another one so that you're given the webhook to another process somewhere, you can give it its own key. So if something happens, something gets compromised, you can actually track by which key's been used, where the event happened, whichever that event may be. We'll go into our code. And in our code, like I said, very simple. Wrong one. Okay, so in this one, all I'm getting is the request and the trigger metadata. In the request is basically the body of the request on HTTP. I import the graph into my script, so it's available in my environment because I put it in my prerequisite, so it's installed. But now I actually import it into the actual running processes. I can create my query. In this case, I want all the virtual machine, but I only care about name, the property storage OS, the property extended instance view, and the power state. That's all I really care about. I want to know what my machines are. In here, I could have added, give me all the tags, but my demo machines, I didn't tag them because they're demo machines and I'm going to kill them this afternoon. And then have logic based on the information you get in order to get the next step done. So what we end up with is get VM status. I send it. Right now, process is starting up because it's been a couple hours since the last time it ran. So it is a cold start. Shouldn't be too long though. And it's always longer when you're staring at it. So look over here. And now I get the list of my 3 VMs. Demo 1, Demo 2, Demo 3, that are currently deallocated. So, I didn't make the link. I didn't have time. But what we could have done is have that fed into the queue and then the next stop, bring it up. But you may not want to start those VMs, all of those VMs automatically. So in this case, I want to start one, but I just want to start demo 3. So to start my VM, which is VM start action, and VM start function in my function.json. Maybe she had just, yeah, start queue. I start queue. In my JSON, I have an HTTP request, a trigger. That's an incoming. I'm looking at the request, and I'll respond to either a GET or a POST. I am also going to send the information back out through the same HTTP session, but I'm also going to out that information or the VM name into a queue that's in a storage account, and the queue name is VM start queue. So I send that information. If I go to my VM start queue, once it responds, because of course, doing a cold start. If it happens within a certain delay, and you can configure that delay, your machine, you can control how long it stays idle before it's dropped. Again, there's a cost to that, so be careful with that. That's all I'm saying. All right, so the virtual machine demo 3 is queued to start in our browser. And now I can go here, refresh, message is already gone. Why? Because my next session or my next script took the information out of that queue, which is the name of the machine that I'm trying to start, based on its binding. So it's looking at VM start queue in that storage account as a start trigger in order to get the information, get the VM right, and then start the VM as job. And this is very important. PowerShell scripts, typically, especially if you're running start-az or anything where you're sending the command to Azure and then it waits for the JSON return. This is stateless and this is task-based. My function will end in a lot of cases before Azure has responded. So we say as job, so we issue the command and then we move on. The event grid will pick up that the machine has restarted, and then you can have another function that looks at the event grid in order to now send the message saying machine 1, 2, and 3 have been restarted today. This is all the way you've done it. Now, if we're looking at our logic app, I have a logic app that typically works in conjunction with that because I find logic apps are better or easier for me to send information to Teams, to send an email through SendGrid, to send information elsewhere, to modify, just like Power Automate, where when it occurred, so in this case I'm looking at the event grid. So I'm looking at event grid topics. The topics I'm actually looking at are successes and failures in my Demo 1 resource group. Because if I'm scanning all of the event grids everywhere, there's a ton of them. So this is my filter. And write success, action success, and delete successes. Once I have those, I look at a condition that is, do my successes or failures contain VM, compute virtual machines? If so, go. If it's not about a virtual machine, then don't do anything, you're done. So if there was you wrote a file to a storage account, that was a success. Does it have anything to do with virtual machines? No. Then I move on. Then I call another function to get some metadata into what time it was, what's the, who started it. Like you can have all of that information. It's all available to you. Then I parse it, and then I post it to a message board, and then I end up with something like this. Of course, considering I did that fairly quickly, didn't have time to format it to make it pretty, but once you have the data, especially in Power Automate, you have a lot more control. I wouldn't say a lot more control, but it's easier to control how you format and prettify your data so that your manager will look at pretty pictures versus JSON files. And that is about it. Functions and logic apps and Power Automate, thank you for bringing that up, by the way, are a great way to take in many organizations very large scripts, very involved scripts, break them down into essentially microservices. So if I need the status of a machine, I can just hit the task that will bring me back the status of the machine. If I know out of the bat that a machine VM demo 3 is turned off and I need it for the demo I'm doing in an hour, I can just send the request with the body of demo 3. I don't have to wait. Like you can use each task individually or use them as a workflow to get your work done. So the basics of this session is really that there are better ways to trigger the execution of your workloads. And based on the number of triggers that we have through Logic App and Azure, it's a great way to get, and Power Automate, sorry, forget. Donna's gonna kill me for having omitted this at the beginning. And that's it. Any questions? It's hard to go through everything in 45 minutes, so I gave you an overview.